All right. First of all, I'd like to thank everyone who is joining us today. Welcome to today's first Eastern Canada CNCF virtual meetup of the year, Canadian Cloud Native Stories. I'm Archie, organizer of Eastern Canada CNCF meetups. I'm also CNCF ambassador and hybrid cloud specialist at Google. And today with me, I have Julia.
Hey, everybody. I'm Julia Simon. I now work actually in HR at CloudOps. So we're super excited to be here. As Archie mentioned, we're going to be moderating with a couple of our co-organizers the event. So yeah, feel free to ask questions in the chat. We'll be getting to those questions for our speakers after each of their talks. So obviously we're doing online meetups. This whole COVID situation has forced us to cancel our Q1 meetups. We were pretty excited about the venues that we had, but here we are. We've restructured. Archie will talk a little bit about some formats that we have coming up. So we're looking forward to doing more of these events as we need to be online, and hopefully we'll be able to be in person again soon, seeing each other in person soon. One thing that I wanted to do was introduce the new, well, I'm going to get to our speakers actually. Sorry, Archie. Yeah, that was the right slide. So these are the communities that we're servicing. Usually we do meetups in each of the 5 cities. So we do Montreal, Quebec City, Ottawa, Toronto, and Kitchener-Waterloo. So for these online meetups for right now, we're going to be doing it for all the communities in all the cities. So hello, everyone. It's kind of a cool way to get to know one another. So we're not always in the same place at the same time. So our communities are growing. As you can see on the slide, there's lots of people in each of these cities that are members of our meetup pages. So yeah, looking forward to being on the road again, but in the meantime, we'll be sharing the online space. So we have a bit of a new organizing committee structure. Archie and I and Carol and a bunch of people have been involved for a really long time. And now we've actually opened it up a little bit more, and we're trying to have different organizers help us in each of the different cities. So we wanted to introduce everybody to them. You probably know most of them anyway, but this is the formal, nice part of this. So in Montreal, we have Alex and Anthony who are helping us. They're online here, you can see them too. In Ottawa, we have Suvro, Ray, and Chris. So super stoked about that. Great lineup there. Toronto, we have Jason and Dima joining us. Jason's online as well, he'll be presenting. In Quebec, we have Carole and Sébastien who are helping us. And last but not least, Kitchener-Waterloo, we have Christopher from Shopify who's helping us, and he's a long-standing member of our organizing committee. So many thanks to him for all his efforts in Kitchener-Waterloo and getting that started. Super happy to have the team together. We are going to be doing more of these events. We have to figure out what the cadence of that is going to be. As Archie will mention, we have 2 formats. So we're trying to figure out if they should be monthly or quarterly. So if anyone has any feedback, we're always super happy to hear from you. Next
Fantastic.
up,
Thanks,
just
Julia.
Talk about our sponsors in the next slide.
Sure.
And say thanks. So just so we can go over these, we have some really great companies who are helping us run these meetups in person and online. So we definitely want to make sure that we're thanking everyone for their contributions and speakers and funds and all the things that they do to help us make these meetups possible. And we have one new sponsor, which is super exciting, which is AWS. So we want to send a special thanks to them for getting on board with us. So yeah, Archie, take it away.
Awesome. Thank you, Julia. So before we're going to get started with presentation, we'd like to share with you some announcements. So our organization team is currently working on a new website for the meetups, but in meanwhile, we're introducing our Twitter page at Cloud Native CA, and we're inviting you to follow us on Twitter, and you can learn the latest news and events, and also hopefully you can help us to reshare the announcements. Talking about events, due to COVID-19, we decided to stop doing face-to-face meetups, unfortunately, which we love them a lot. So we're going with 2 new formats. of the meetups. So the first format is a virtual cloud native stories. It's kind of our effort to try to give an opportunity for local and user speakers with the goal to share user stories with the community. And each speaker will have 10 to 15 minutes. All speakers will receive a nice CNCF swag. And it's a very low entry, you don't have to spend a lot of time. We pretty much like found the guys last week and they already prepared those 4 presentations for today. But obviously, if it's a very interesting presentation, please let us know. We can give more time for the speaker to come and present in a more longer event. And this more longer event, something what we called second format, which is Tech Talks, where we're hoping to invite CNCF ambassadors, CNCF project maintainers, community members, sponsors, who can do cool project talks, cover some topics, maybe some tools, and we can provide them 45-minute format for that. So yeah, that said, obviously we're looking for your feedback. If you let us know if you like those 2 formats that we're trying to bring. We're also thinking if you want to organize something in your city, some like a gathering or maybe lounge cafe for Ottawa, let's say, community users. Please, we have already like organizers locally. You can potentially organize some of those events. But those are 2 events that we're planning to have right now coming forward. And another fantastic news for the community, we want to announce a brand new CNCF-backed community event, Kubernetes Community Days, or KCD for short. And this will be pretty much in the city near you. So the goal of KCD is to bring KubeCon-like event near you, and it's organized by community and for community. And if you're interested to join as an organizer or sponsor, please find your city in the GitHub that you see the link below. And you can pretty much let us know or CNCF know that you want to be organizer or speaker or sponsor. So KCD has been planned to take place in 2020. Unfortunately, due to the situation around COVID, we decided to postpone all events until better moment. So please stay tuned to updates on our Twitter or Slack channel. Regarding our Slack channel, we did some cleanup on the Slack because we've seen that a lot of channels, like over 60 channels, were not used very often. So we will kind of remove them temporarily. You can, unarchive them if you need it. And we also introduced some new channels. One channel is called Announcement. This channel will be mainly used by organizers to announce some important announcements, news for you. And then we'll have a new channel, Discussion, which is basically can be used for any cloud native tech topics. So you can discuss, if you have any question or if you have something cool to share. And also you see other channels there pretty much that was before. We're also introducing a channel per city, Ottawa, Montreal, Quebec, Toronto. So, if you want to discuss local pubs and bars, or you just want to, meet with each other, or if somebody's traveling, you want to get some advice, please join these channels and, stay active, help us to grow the community. So with that, I would like to welcome our presenters today. Don Bowman, founder at Aglicus from Kitchener. We also have Nasim Ullah, DevOps at Transit from Montreal. Julian Mazzitelli, CIO at BioBox, and Jason Hadi, SRE at Ecobi. They are both from Toronto. Oh, okay. So I think we can give a Don stage to prepare to present. I'm gonna stop sharing and pass it to Don. Before Don is gonna start, I would like to just go over some housekeeping items. During the online meetup, you're not able to talk as an attendee. There is a Q&A box at the bottom of your screen. Please feel free to drop your question in there and you'll get as many as we can by the end of the event. And with that, I'll hand it over to Don to kick off today's Cloud Native Stories. Welcome, Don.
Okay, thanks very much, Archie. Everyone can hear me okay?
Yeah.
Okay. All right, so let's just make sure the slides are moving. I'll give you 2 seconds about us. So we are a small company based in Kitchener-Waterloo, and we're very passionate about the intersection of cloud, security, DevOps, and open source. And our mission is to digitally transform municipal IT using these concepts and technologies. So take things that are historically very non-cloud native and move them there for them. And we do that, we believe very firmly that security and cloud native can actually increase efficiency. There's this concept out there where you have to put a firewall in at the door, and that's a single entry item, and that's very non-cloud native. So that's kind of our strategy, is to rethink how security works so that it's throughout the system. My high-level strategy, and that's what's driven a lot of the technology decisions, is the first thing I look for is open source with active communities. So, you know, there's a lot of things that are kind of open source, but there was one pull request last year, and I try not to get involved in that unless we're prepared to take it on as a maintainer. You know, otherwise we might look to open source something ourselves if there's no active community. That's one of the things I really like about the cloud native ecosystem. Generally speaking, each of the projects has people that are passionate about it, which means it drives very quickly. The second part of our strategy is everything has to run on Kubernetes. We don't run any pet sets. So things that you'll see in the next slide, where we talk about relational databases, these are things that historically haven't run that great on Kubernetes, and we've sort of put our backs into making that work. We want everything to be cloud native, and by cloud native, I mean it's dynamically scaling in and out. It's accepting failures all the time. A big part of our strategy, all of our clusters, we use 100% preemptible nodes on Google Cloud, which means that the chaos monkey comes early and comes often for us. And we've designed our entire ecosystem to allow for that. We use Kustomize for 100% of our sort of operations, and we do that via GitOps. So things get checked into Git, and then we use Kustomize to do the deploy. We don't use Helm at all. We have one deploy directory per cluster, which means that 100% of the cluster is applied all at once in one step. There's no ability of someone to sort of, you know, edit one namespace or one deployment. We do secret management via SOPs. If you're not using Mozilla SOPs, I really recommend you take a look at it. It allows us to have our secrets stored in Git and be safe. So by secrets, I mean, you know, passwords and TLS keys and so on. A big part of my strategy is zero trust. So a lot of people have this sort of security model of outside bad, inside good, and they sort of run everything internally without TLS, and passwords are just in the clear. We assume that the internal is already compromised, and therefore we have to have security at each layer all the way through. And that's driven a decision around network policy, Istio, mutual TLS, etc. And the last part of our strategy is we self-host everything. So other than GKE, we don't use external services, like we don't use like Postgres as a service or something like that. Our basic architecture, we have two types of things. We have one singleton cluster we call our NOC, and then we have one cluster we call our hosting cluster, which is by geography close to our customers. And that one is multi-tenant. Within it, each customer gets a namespace. Kubernetes is not really designed in its security models for multi-tenancy, and that's a lot of the tooling we've put in. So the tools that we've used to do that, we use Envoy. We use Envoy quite a lot. We use it outside of Istio. We use it as a basis of our firewall. We're one of the contributors to it. We also use the Open Policy Agent, OPA. We use that for all of the API controls internal to our system. So rather than coding it in each API, in our Open API spec, we express something, and then we use Rego and OPA to have it take effect. Everything within these clusters is all mutual TLS, courtesy of Istio. A couple things I would call out from the CNCF ecosystem that we're pretty happy with. I'll talk more in the next slide, but we use TICV, or I'm not sure how you pronounce it, but the TIDB project's key value store. That solved one of the really key issues that we had. We put Titan on top of it, which gives us a cloud native Redis without having the traditional problems of Redis clustering. And then we use a lot of the same technologies that everyone else does, like Prometheus and Alert Manager and so on, Elasticsearch. And CockroachDB is one of the other heroes for us, which is a relational database that's very cloud native. So things that I would say that we do that are a little bit novel that I would share with the crowd. The first is we use Fluent Bit everywhere. So we don't use FluentD. And one of the things we do that's unique in Fluent Bit is each of those hosting clusters, they sweep up all their logs with it, they enrich it, they add the Kubernetes labels, etc. But then they use the Fluent forward mechanism to send it to our NOC, where it's received by FluentBit again, and then it's inserted into Elasticsearch, where we use our logging. And this is, I think, a little bit unique. It means that we don't have the traditional FluentBit to FluentD or other architectures. We use TLS client certificate authentication for that. We also use FluentBit as a gateway into Kafka and Druid. Our big data solution, our columnar store, is based on Druid, which unfortunately requires bringing in Kafka. That was one of our main challenges, was the sort of Kafka, Zookeeper, Druid, the Java components there were not very cloud native, and we had a lot of work to do to get it there. The Titan, so Titan is an application that sits on top of TickV, and it provides a Redis facade on that underlying shared out key value store. And it's really, really fantastic. It's intrinsically multi-tenant, so each sort of authentication key you log in with, it segments all the key value pairs by that. So you can run one copy for your entire cluster and scale it quite nicely. 100% of our APIs are based on OpenAPI 3. So we specify them in the OpenAPI 3 YAML, and then we use code generators to build our SDKs. We implement the code backend in Python. But something that's kind of unique here, a lot of people use OPA for their sort of their RBAC control on Kubernetes, but we also use it for our APIs. So it controls, based on our JWTs, who can do what for us. We have a custom use of Envoy. So we have our own build of Envoy with some things that we're still working on upstreaming. And that allows us to do very fine-grained role-based access control, including on the payload. So on behalf of our customers, sometimes they want only allow a post to this endpoint if the body is JSON and field A is equal to this value from the JWT. And another thing that I think is a little bit novel is CockroachDB. So CockroachDB is a Postgres-style database, but it's sort of shared nothing, or sorry, it's scaled out across your cluster. What we do is we run a single shared cluster of it, and then we have a CRD-based operator. So in Kubernetes, we can create a YAML document that will cause a new database to get created in that shared Cockroach cluster, which is more economical and easier to scale. So the last thing that I thought I would just highlight from our story, the TickV and TIDB were relatively recently introduced into CNCF, and it really filled a big gap for us. CockroachDB has been very amazing for us, but we needed the same for this sort of real-time key value caching that traditionally people use Redis. And we had a couple of options. We could have used a managed Redis, but back to my last point earlier, we self-host. We could have run it inside Kubernetes with the Helm chart, but it's relatively challenging to get a high availability Redis cluster when you have 100% preemptible nodes. And we've managed to achieve that with TickV and Titan. So it's been really, really fantastic for us. And that's sort of the architecture there on the right. We have multiple applications that each think they have their own unique Redis. And that's because of when you authenticate to it, it gives you a different namespace in it. And it really has been quite awesome for us. It's very resilient to scaling in and out, and very resilient to temporarily losing a node. And then it provides the same Redis facade that we're all familiar with. So with that, that's all I had to present. If there are any questions, I would love to take them.
Hey, thank you very much, Dan, for this great presentation. Actually, we have some questions, actually. First question from Eric. Why do you call it self-hosted instead of self-managed? He has never seen self-host in that context before, and it's usually strictly used. I mean, is it usually strictly used for on-prem?
You may be overreading my words there. I mean what you mean. So we use GKE to manage the nodes, and then everything inside it we manage. So self-hosted, self-managed, I think you know what I mean. I'm not being specific.
Thank you. We have another question from François. He's asking you about the 100% preemptible nodes. Do you see a risk of a possibility that there is a lack of VMs available from the cloud provider? And if you have less nodes in your cluster for some time? If so, how do you mitigate this risk?
So we do that using the node autoscaler in GKE, which has a cost-based rule. So we have one node pool, which is 100% preemptible using N1 style nodes. We have one node pool, which is 100% preemptible using E1 style nodes. And then we have one node pool, which is non-preemptible using N style nodes. That one nominally has 0 scale, and it's used as a node pool of last resort. It will be brought online in the event that there is nothing available from the provider. But yes, there is some risk here, I think.
Thank you. I got another question from Suvro. Is there any reasoning behind not using Helm? Because I think you talked about customized. So I guess the question is why customize instead of Helm?
So a couple reasons. So the first of all, I understand there's been some differences now with Helm 3. Helm 2, I couldn't accept the security model. Going back to I'm assuming that I need zero trust. I need to not have one single point of infinite trust. And Tiller broke that trust with me. And the second problem that I had with Helm, I contributed a bunch of fixes to Helm charts, and the maintainers were just completely overwhelmed. It was not a very good experience. It was many, many, many months. And the third problem I had with Helm is I don't think Jinja is the right tool. I was constantly getting something where I'd end up with invalid YAML out of it because it was a spacing was off by 2 because it was very difficult in Jinja. And I just lost trust in it. Kustomize has worked a lot better for us. It allows us to patch in the behavior we want with the JSON patches. We invented a concept called a K-chart, which is effectively a Git repo for each application, and it behaves like the Helm chart, and then we customize it. And it works better for our GitOps flow, to be honest.
Thank you. We also have another question from Adrian. He's asking if you use OPA directly or if you use OPA Gatekeeper. If you don't use the Gatekeeper, why doesn't it work for your use cases?
So we don't use Gatekeeper. We use OPA as both a library in process in some things. We use OPA as a service. We use it with the authz endpoint of Envoy, and we use it directly integrated with our applications. To be honest, Gatekeeper wasn't around when we started using it, and I have looked at it, but it doesn't seem to meet the needs. It seems to be more, anyway, perhaps I should look at it again, but it didn't seem to be appropriate for us.
Thank you, Dan. Still 2 questions left. What are the major, so it's a question from Arabi. What are the major challenges encountered making Druid cloud native?
Oh my. So Druid at the high level should have been very easy to make cloud native because its architecture is designed to be able to dynamically scale things out. It has no state other than blob store, which we use GCS for, and relational database, which we use Cockroach for. The main challenge was they'd never built containers for it. And the upstream didn't really seem to believe in the container architecture. So I contributed the Docker file for it. It took a while to get adopted. The second is they were tied to Java 8, which has very poor support for C groups and memory utilization. And the third component was it was very, very difficult to configure. It wasn't native for configuring with environment variables, which is the environment, which is the style of Kubernetes. You had all these millions of files in a million spots. And then I guess the last one is it forced us to use Zookeeper and Kafka, which are also challenging to run in a Kubernetes environment. But at the end of it, it worked fine.
Okay. I have a very ultimate last question for you from Servo. Do you use Kubernetes Federation to talk between clusters? And that's going to be the last question.
Do I use which to talk between clusters?
Kubernetes Federation.
Oh, no, we do not federate the clusters. There's really not a reason for us to do that. We use OpenAPI and our services between them, but they are each independent from a etcd and deploy standpoint. The only federation is really on the logging with Fluent Bit, I suppose.
Thank you very much, Dan. Now let's move on to the next presentation. Thank you for your questions too.
Thanks, Don, a lot. So we're gonna go with next speaker, Nasim. He just reached out to us recently and tell us, today's his birthday. So, it's very courageous to present at the CNCF meetup at his birthday. And he asked us, if we can do, instead of, just slides, we can go over like a fireside chat type conversation. So we put it some kind of a background of the fireside. So if you see me and Nasim right now sitting in front of the Firebase. So go ahead, Nasim.
All right, thanks, Archie. Hi, everybody. So my name is Nasim. A little bit about me. I'm a Kelsey Hightower fanboy. I've got a couple of certifications, including the Kubernetes ones from CNCF. I maintain Helm charts for Jaeger and Fluent Bit. I can be reached at Nasim K. Ula at Twitter or GitHub. So feel free to reach out after this talk. And I do Cloud at Transit. So a slide about Transit. It is an application that allows you to get from point A to point B without your own car. So that's buses, streetcars, trains, bike share, ride share, car share, all at a glance in one beautiful app. We've got users primarily in North America and Europe, as well as Australia, New Zealand, Buenos Aires, and we are continually expanding. We use a bunch of cloud native projects at Transit, primarily Kubernetes and the surrounding ecosystem to kind of improve that experience. So
fantastic. Yeah. It sounds very exciting what you guys are doing. Can you tell us how you run your Kubernetes clusters? Do you bring your own cluster, you go to the vendor, or use managed solution?
Yeah, managed solution GKE, primarily because we want to focus on delivering our app rather than building and managing the Kubernetes control plane. And the managed offering from Google Cloud suits our needs.
Fantastic. So you just showed like the map, you have customers across the world. It's probably very challenging to, to deploy such an application. Can you tell a little bit of, what are the challenges you have when you're deploying such application in distributed manner?
Yeah, so basically getting the APIs closer to the users is something that we're working on. Right now, we run primarily in one region, but we're working on formalizing a global strategy by making use of a global IP offered by GCP to kind of direct traffic closer to the user. We're using CDN for static content, but it's more about the real-time data. We still have to discuss with our team how to split up or replicate the data.
Hey, check out in our Slack channel. Maybe people can, share some their experience.
Yeah, if you're doing global stuff, please let us know how you address data.
Great. Can you tell us how you automate your DevOps tooling that you have here? Like you have Prometheus, Fluentbit, all this, Linkerd, some other like Jaeger, how you automate this deployment, and also how you automate your Transit app deployment as well.
So regarding third-party open source software, such as like the CNCF projects that we deploy in our Kubernetes cluster, we do use Helm by means of a tool called Helm File. Helm File, it basically replaces what you could use a bash script to like install your various Helm charts to your cluster, but Helm File is more declarative than that. I have a link in the last slide to an article I wrote about how we use Helm File at Transit. And for our in-house apps, we had originally gone with Helm, but we are actually moving towards customized, which is a little lighter weight. And while I think Helm is really good for sharing third-party open source apps, in-house customized is like a lighter weight solution that we're moving towards. And we do GitOps with a push model with CI/CD rather than like running the newer way of running an agent in your cluster like Argo CD or Flux that's constantly checking the status of constantly syncing what's in Git to your cluster. We do the like traditional CI/CD approach. I still consider it GitOps because we declare everything in Git.
Interesting. So Don just mentioned that, he doesn't trust Helm as much because of the tiller problem. Are you guys still running on Helm 2 or you moved to the Helm tree?
No, we agree with Don on that. And we quickly moved to Helm 3 once it was available. There was a blog post written by Remus from JFrog, who's like a Helm wizard, and he basically wrote a step-by-step article on how to migrate to Helm 3 and pretty much followed that to the T, and had very little issue, like one slight issue, but it's been addressed, and I'll link it at the end of the talk if interested.
Can you tell us about a little bit, like you mentioned that you're contributing to the CNCF Helm charts, how hard it is and why you're doing this, and what's the story there?
Yeah, basically, I think a lot of people probably share this feeling, but you kind of treat open source software like it's your own. You're deploying in production. You want it to be as good as possible. And it all started with a simple image update on one of the Helm charts. And ever since I've been contributing. Before you knew it, I'm like top 10 out of 3,000 plus contributors on the stable repo, which is now deprecated, by the way. Helm is moving to kind of like decentralized model for chart repositories. So what was the question?
That's pretty much it. Like I was just more interested about how you're contributing and how hard it is to start contributing. Is it like, can anybody from us go and start contributing to the Helm chart, or it takes something to do?
No, doesn't. You just got to sign a DCO and just go for it. Start small, I guess, it kind of happened organically for me. I just started small, image updates, documentation fixes, and before you know it, doing features. And
great. You have any like tips and tricks from the Helm,
Yeah, well, now that charts are kind of decentralized, you can't just go to stable repo and look for your chart anymore. So I'd recommend going to the Helm hub to kind of look for charts that you need to deploy in your cluster.
I went there recently. I saw like 4 Nginx charts. Which one I should use?
That's a good question. What to say? I know that Alejandro, like the maintainer of Nginx Ingress, is hosting a chart now in his repo, so that's probably a good option. Bitnami as well is trustworthy. They run their stuff for their
Well, we're just gonna ask Nasim next time which chart we should use. You're probably familiar a bit.
I'll give you my 2 cents.
Okay, great. So enough about talking about application deployment. Does transit is like microservices or monolith architecture as an application itself?
I'd say mostly microservices. Yeah.
Okay, interesting. And do you have any like adoption obstacles for microservices? Like any challenges and how to run distributed application and also microservices in Kubernetes?
Yeah, so communication between the microservices can fail intermittently via HTTP. So you could implement something like a service mesh, which is really cool. Well, no, sorry, that might be going too far. Like you could in code implement retries. But I find service mesh is really nice for platform owners because it's kind of a platform problem. The whole networking thing, like when services can't communicate with each other, if you could configure that on an infrastructure level, which service mesh allows you to do, it kind of empowers the platform owners. So that's nice. And yeah.
I see. Do you have like, what do you do for observability of microservices? How you tackle challenges with regards to tracing, logging, and monitoring?
So tracing is kind of a cherry on top for us. It's not crucial for our day-to-day operations. We're not like Uber with like 1 billion microservices, like very long chains. But we are dabbling in it and quite happy with using OpenTelemetry for our Node.js apps, because there is an auto instrumentation kind of feature, which I think it's crucial if you want to do tracing across your organization. So, and we send that to a Jaeger backend that's backed by Elasticsearch, and that's how we tackle tracing, and it's just in staging today. So like I said, it's not crucial for our day-to-day operations, but we plan to deploy that into production.
How about logging?
Yeah, so we use FluentBit, just like Don, but not in the same way that we're more like basic. We just kind of send our logs straight to Elasticsearch. What we find really nice is when the applications log in JSON, because with structured logs, we could kind of aggregate the logs better and search through them and even create alerts. And there's this project that I want to kind of shout out because I think it's kind of underrated maybe a little bit, but Yelp have created something called ElastAlert, which allows you to create log-based alerts, which it works well for us. So just wanted to kind of.
And what's the reason behind going with FluentBit versus FluentD, which is like pretty much, same part of from the same CNCF organization, but like what was the driver behind that?
Yeah, that's an easy one. FluentBit consumes less resources.
So you want to save some money on it, right?
Yeah, that's an easy choice.
Great. And finally, what about monitoring? Like how you monitor your microservices?
What's very crucial to our day-to-day operations is Prometheus, where we gather a lot of metrics about our Kubernetes workloads, memory, CPU, how many restarts the pods have been having lately. And we basically all the services we run there kind of export metrics in Prometheus format. So yeah, it's very crucial to create nice dashboards to know what's going on and alerts as well. One in particular is the Nginx ingress controller that we use exposes Prometheus metrics that we collect, and we create alerts based on error rate and latency. But once again, this is only for user-facing services, but not internal service-to-service communications. So with that, I just circle back to service mesh, which helps us get those metrics on a per service level.
Interesting. So you mentioned service mesh, and you have Linkerd here. I assume you also do securing your microservices?
Yeah, so Linkerd gives us mutual TLS out of the box, which improves our security for sure for mesh services, of course. Yeah.
I see.
And I mentioned the retries that we use.
Okay.
Service meshes.
Was it hard to implement? Like how long it takes to introduce service mesh into the application stack?
It was relatively easy. I won't say easy because nothing's easy. So it was relatively easy. And I've got a blog post I'm going to link at the last slide about our story with Linkerd.
Okay. I think I have my last question of the day. Why, Transit, went with the Linkerd? Like there's also other service meshes out there like Istio and Console, and there's like huge other variety of meshes. Like what was the main driver behind that?
Yeah, so we were kind of looking at both Istio and Linkerd. They're both great solutions, I think. Console as well, but we weren't really looking at that one for whatever reason. I mentioned this in my blog post as well, but it was kind of there's this blog post by the CEO of Buoyant, the company behind Linkerd. It's at servicemesh.io. It's just a really good blog post on service mesh, like what it is. It's a very entertaining read. So that started to lean us that way. And it just seemed like the lighter weight solution, which we tend to default to. And they have a really, really amazing Slack community, very welcoming, very responsive. I ask questions all the time and they're always answering. So.
Well, thank you very much, Nasim. I hope you can share your slides with us as well so we can share with the community.
Yeah, sure.
Anthony, do we have any questions for Nasim?
Yes, indeed, we do actually. Thank you very much, Nasim and Archie. We have a first question from François. François was asking what were the reasons you decided to not pull the to not use the pull approach in your GitOps process? Because I think you mentioned that you were just using regular CI/CD. You were not using tools such as Argo CD, and I think he wants to know why you're not using this pull approach.
I think when I started like implementing this whole thing about almost 2 years ago. I don't think Flux and Argo CD, maybe I just didn't know about them or they weren't mature enough then. I'm not sure. This was like almost 2 years ago. So I just went with CI/CD and it works for us. We haven't had any issues that made us want to switch to the pull approach. So I think it's a great approach as well. So yeah, I just didn't know enough about it when I implemented this thing, and push works.
Okay. We have another question from Younes. Well, actually, it's two questions. He was asking if you are using Stackdriver for tracing monitoring, and also his second question is wondering if your GKE is zonal or regional.
Okay, those are good questions. We're not using Stackdriver for our Kubernetes specific things. We're using open source tooling. We do use Stackdriver for like other Google Cloud services. And the second question was, oh yeah, we use a regional cluster. We might move, like I mentioned, we want to formalize our global strategy. I do think we'll have various zonal clusters at some point. We won't have various regional clusters. Interzonal network fees are kind of expensive. And they do make the control plane HA. Oh no, sorry. They make the data plane HA, but not necessarily the control plane. That's to say, scratch that. I'll take it offline, that one. I'll have to think about it more.
Okay.
Oh, we use regional today, but we
Okay.
think of many zonal clusters in the future.
All right. Francois had the second question. He was wondering if you complement customize with something else to deploy your app in Kubernetes, for example, something like K-app, or if you are using directly kubectl directly with a customized build manifest.
Yeah, so we're using the standalone customized CLI tool, not the one that's bundled with kubectl. I think there was like a feature that was missing because it's not the latest version. And we use the customized cloud builder image, and specifically we use it in our CI system. There's a customized image that we use to deploy our app, not in conjunction with anything else, just customized with the customization files.
Okay, thank you. And this is the last question for you from Sebastian. He's wondering if you could share a text list of all the apps that you're using.
All the apps that we're using?
Yeah, a text list. So this is why he's wondering about if you have this somewhere shared in across your links or somewhere.
No, but I could type in chat, like the third-party apps, right? Like
yeah, it's basically something from slide 5, you know. So you had all the logos. He was wondering about text version.
Yeah, sure. I will share a text version in, I guess, the chat.
Yeah, well, would work great.
Cool.
Thank you.
All right, thank you.
So we're going next with Julian. Julian, are you ready? Thanks, Nasim. Happy birthday again. All right, thanks everybody for the good questions. If you have more questions, the speakers will be able to answer you in the Q&A box. And with that, I will be passing mic to Julian. Go ahead, Julian.
Great, thank you, Archie. So, hello everyone. My name is Julian Mazzatelli, and I'm the CIO at BioBox. Today, I'm about to speak to you about how we unify development and operations using CNCF incubating Argo CD. A little bit about BioBox to start us off. So here at BioBox, we are building a data analytics platform for clinicians and biologists working with genomic data. Our stack runs on Kubernetes, and we run ephemeral workflows on Kubernetes as well. So I'm about to explain to you guys how Argo CD has improved our developer experience. First, I will do a quick overview of what GitOps is and how Argo CD performs GitOps. Then I will explain the problem we had, which was our development environments were not matching production. I will explain how Argo CD proposes a solution for that problem, and then finish off with the developer experience of the solution and how the solution affects the organizational structure. So what is GitOps? Everyone's talking about GitOps these days. I like to say that GitOps replaces the deploy stage of a CI pipeline. Instead of running a command to, for example, kubectl apply file in your CI pipeline, you write that file into a Git repo instead. And then there's an agent inside the cluster that is making sure the Git is kept in sync with the cluster, with the Kubernetes API. So we get a bunch of benefits, namely there is auditability. Rollback ability is very straightforward. You can just pick a commit from the past. And we also have improved resiliency. If the state of the cluster drifts from whatever's in Git, the GitOps controller will do its best to make sure those are kept in sync. So how does Argo CD, the two options for GitOps these days, maybe more, but the two popular ones are Weaveworks Flux and Argo CD. So next I will explain how Argo CD is working. Okay, so first of all, your application will be defined by a template. Your template may be a Helm chart, a set of JSON files, customized, or even just plain YAML. For this example, I will be using a Helm chart because everyone is familiar with that. So let's say you have a repository filled with Helm charts. In this case, it is named your organization/templates. And we have a folder inside there called My App. To deploy this app, you would create an application custom resource. The most notable features of this CRD are source.repo, source.path, target revision, and then specific params. So in this case, I'm specifying that I would like to deploy the app defined under the folder My App in the repo templates off of branch master. In addition, I'm specifying Helm parameters directly in line. If you're using JSONit, these could be JSONit top-level params. And as well, Argo CD supports using a custom tool, in which case you can provide an arbitrary environment variables. Next, Argo CD will deploy an application controller, which is doing a watch on all of these application CRDs. Once it sees a new one, it will go ahead and clone plus render that Helm template, given whichever parameters you had in the application spec. From that point on, the application controller will kube apply these resources to the Kubernetes API. Finally, as part of the resiliency of GitOps, when Argo CD will periodically. Hello, can you guys hear me?
Yes, we can.
Okay, I said I was muted. Okay, so yes, Argo CD will reclone on a periodic basis, or you can trigger manual synchronizations. So this is the complete loop of GitOps. We have our desired state kept in Git. The agent pulls it down, executes it, and renders it, and synchronizes with Kubernetes. And finally, make sure that Kubernetes is kept up to date. In this bottom right, this is a picture of the Argo UI. It will show you the resources from Git and their synchronization status as a green check mark. And finally, one extra complicated factor is this deployments. You may use a deployments repository to hold these application CRDs instead of just plainly kube applying these application CRDs. Okay, so that was GitOps. Now I'm going to talk about the problem that we had with our development environment. So we were using Docker Compose, which worked okay. It lets you use the same images that you're running in prod, but your networking stack is going to be a lot different. Everything is talking over typically a single Docker network, as opposed to in Kubernetes where things are namespaced. And a big feature was we weren't having the observability stack be replicated. You know, you could theoretically run your logging stack in Compose, but that's a lot of duplicated effort. And the reason we wanted to do this was so that developers could work on the app in a way that they could practice if they ever had to debug a problem on production. So we felt that having similar observability tools be used by a developer on a day-to-day basis was very valuable. And so we desired to move to Kubernetes primarily for that reason, and as well just so that the stack was as close as possible to production. So how hard would it be to do this? You know, at this point, the operations team was already using Kubernetes to manage the application deploys. They were already using Argo CD. And so we already had a wealth of templates, not just for the bespoke application, but for platform level services, such as an API gateway, logging, Prometheus metrics, etc. So we want to reuse and share this knowledge, but just telling developers to kube apply a bunch of files is too complicated for them. And as well, there'd be a lot of potential for error. You know, there would be configuration drift when new files are pushed. So this was a potential solution, but we felt it was too complicated. So we wanted to provide an abstraction for developers, but then still let there be this sharing of knowledge. So what we've arrived at is the operations team will prepare and manage every developer's own Argo CD, and every developer will get their own Argo CD that has full power over their own namespace. Now our development environment is an exact copy of prod, plus developers are getting a little bit of experience with how GitOps works. So let's go over the architecture of how we achieved that. Before introducing any of this developer specific deployments, we have our organization templates and our organization deployments repos. So our staging and prod environments are managed primarily by the ops team through that repo. The ops team will then create a new application, CRD, for deploying a developer's personal Argo CD and creating a developer's personal namespace. So at this point, the operations team has done all the work so far. Now, a new developer, first day they start working, will fork the organization templates to their own personal account and create their own new deployments repo. When they want to spin up a stack and work on it, they simply copy paste an existing application YAML and change things like the image tag parameters or other simple parameters. This is straightforward and simple because everyone knows how to copy paste a file and commit. Then at this point, they have a copy of the stack running in their own isolated namespace. Let's just walk through a little bit step by step how that looks like for the developer. So this is the story of working on a feature, for example. The developer will create a new application for working on a specific feature, and they can either push it in the deployments repo, use the Argo CD UI, or if they'd like, just k-apply an application YAML locally. Now, the other complicated factor about this development strategy is how do you synchronize your code if it's running in Kubernetes? We found that Ksync works pretty well for us. Ksync is a software that will launch syncthing as a daemon set on every node in your cluster, and then provides a CLI for adding local folders on your machine to sync into the pods. So that has worked well for us. It allows the developer to use whichever IDE they choose and basically have a live development environment that is running inside of Kubernetes. Another option we are investigating is network proxies. So for example, telepresence runs a sidecar in each pod to provide a proxy between your local network and the Kubernetes network. Now, the really interesting part now is when checking metrics or logs, the developer can use Elasticsearch or Grafana and Prometheus. So this is great because on a day-to-day basis, developers are getting practice using the same observability tooling that ops is using. So this provides a greater knowledge share between ops and dev. You know, maybe they can feed off ideas from each other. And if the developer ever needs to help debug a problem on production, they already have experience with these tools.
Julian, we are running a bit late. I'm asking you if you can wrap up for the next presenter, please.
Sure. So just the last thing is developers have the ability to modify those templates if they do have to make changes, for example, adding an environment variable. So just the important bit that I want to point out is that this acts as a black frame, not a complete box. it's a developer user experience, but they can still look into it and fix things if they want instead of waiting for a ticket from operations. And this, again, creates greater knowledge share, somewhere between a type 1 and type 2 DevOps team topology, where there's shared responsibility and shared knowledge. I can take questions now if you have time.
Yeah, thank you very much, Jian. We only have time for one question, unfortunately. We're running late once again. So we have a question from Brad. He was asking about an alternative to casing, because I think you talked about casing and also you mentioned telepresence as well. Have you considered tilt.dev? It's another tooling to think up.
Sure. Yeah, there's a wealth of these Kubernetes development tools available. I know of Tilt, haven't had firsthand experience playing with it. Pretty much when I first looked into this, Ksync, I tried it out and it works, and we haven't had much of a need to go and compare in depth all the available tools. But yeah, Tilt looks like a good option. And as well, like I mentioned, telepresence we are looking to try out.
Thank you very much. On to the last session, then. Thank you. Thanks again, Julian, and thanks for your questions.
Thanks.
All right. All right, so it looks like my is sharing, so I think we're just getting started. So hi, everybody. My name is Jason. I'm a site reliability engineer here at ecobee. I've been here for 2 years. I'm an SRE on the home monitoring team. And you may see me around at various Cube meetups or maybe at KubeCon. And just a little fun fact, I'm a big fan of Scotch. So if you're tired of talking to me about Cube, you can talk to me about Scotch. So just want to introduce ecobee real quick. ecobee is a connected home company. We sell IoT devices and services for your home. We're most known for our smart thermostat and our remote sensors to set up climate control for your house. We're well over 1 million thermostats connected to our home, and of course that's caused some interesting scaling challenges for us. But recently we also branched out to other products, including our smart camera and door and window sensor. We take all this data from these IoT devices to build smarter services that consumers can use, such as Eco Plus, which uses machine learning to sort of optimize their energy usage to save you some money. And ecobee Haven, which is the product I work on, which is a home monitoring product to sort of use occupancy and presence data to detect whether someone is home or whether someone is at home and they shouldn't be. So ecobee uses a lot of CNCF stuff, and we're really happy with the work that CNCF does. We think it's really important and helps kind of move everybody forward altogether. We're big users of things like Kubernetes, obviously, and Prometheus, and we're also users of some other stuff like Helm and gRPC, which really make our day-to-day operations and development experience really, really different. So just a little bit of a story. We weren't always cloud first. ecobee's been around since 2007, so we had the infrastructure to match. We definitely weren't cloud first. You know, our infrastructure looks something a little like this. And I'm sure if you look in your confluences and wikis, you'll see something similar like this, maybe even the same icons. And we carried this infrastructure quite a number of years up until fairly recently. You know, we had launched other products during this time, such as our light switch, and those went to the cloud, but our thermostat infrastructure always stayed on premise. So you might think, okay, let's take the common Germany, let's ditch the data center and reap that sweet benefit of on-demand compute. But spoiler alert, we didn't leave our colo, actually. We stayed on premise. So that's where things like RKE came in. So we wanted to leverage like the benefits of Kubernetes. Kubernetes is amazing at the resiliency and the benefits of the developer experience, and the ops experience is just ways ahead of whatever we had before. So, but we all know maintaining a Kubernetes cluster on its own can be a little bit challenging. So RKE helped bridge that gap a little bit, gave us the confidence to maintain that Kubernetes cluster on premise. And it also had a great new node onboarding experience. It worked well with our provisioning setup. So that was really good because it meant we could slowly decrease capacity on the legacy setup and move that computing power over to the new setup as we've scaled it up. So here's what it sort of looks like today. We're not 100% there. There's still bits of the legacy still around. but this is what our new info setup looks like. Now, a lot of the same elements are still there, such as that firewall and some of the network equipment. But now we've done away with those pets, no more web, 10, 9, 10, 11, 12. Instead, we have a fleet of Kubernetes nodes, which look relatively identical. The interesting thing that we've done actually with this setup, though, is we've used MetalLB, which is a sort of the load balancing layer you can set up with Kube, where you can actually set it up in BGP mode. So we've integrated it with our routing equipment so that they exchange BGP routes and use equal cost multipath routing to more evenly distribute the workloads that come from our thermostats. Our thermostats have a little bit of a long-lived connections, and they're a little bit sensitive to bouncing around between different nodes. And BGP really helped us stabilize that, and also gave us some benefits of network discovery, and again, mentioned the stability came with it. The workloads now get on there via Helm, which come deployed via Circle CI, and any local storage is done with Rook and Ceph. We're still not done with this picture, though. Like, there's still some bits that we can definitely improve on, such as that dangling database at the end, and that's where stuff like Vitess can come in. The whole thing was and still is monitored by Prometheus, and metrics are exported with a number of different exporters. But many of our other products are on GKE. So ecobee runs a bunch of different product teams like home monitoring, Eco+, and we tend to make them a little bit of autonomous. I think the Spotify squad model with some tweaks. So that means that each product team is actually autonomous in its choosing of its own tech stack and also responsible for its own infrastructure. So our Google Cloud present looks a little bit like this. So again, heavy users of GKE, but it goes in a simplified fashion. It looks like home monitoring has its own cluster, Eco+ has its own, data science. It's kind of that, you got a little bit of that Oprah, everyone gets a cluster. Obviously there's challenges and cost implications with this, and we're looking to sort of optimize this, but this has really helped us with our time to market and our R&D. Naturally, though, we have kind of converged on a solution where each team is leveraging Circle CI. We deploy either our in-house Helm charts or community Helm charts from Circle CI. And a lot of us tend to use actually the Prometheus operator to monitor everything that we deploy and make sure it stays healthy. Data science looks a little bit different, obviously, since we're not serving applications. They use things like kubeflows and manage their own workloads. So just some specifics. Helm, we're actually still, a lot of us are still using Helm 2, but with Helm 2, we've really leaned on the tillerless plugin. We, like many, didn't like running tiller inside our clusters, and the tillerless plugin helps really remove that headache, although hopefully with not much longer, as most of us should be moving to Helm 3 in the near future. We do use a lot of plugins. Nasim mentioned Helm File. We use Helm File as well. It's been great to help manage a lot of those Helm charts. We've run some Helm GCS Helm repos just for some internal stuff, and Helm diff to help generate some of those more human readable outputs when you're deploying Helm charts. And some of the Helm charts we deploy, we're big users of Nginx Ingress, Prometheus Operator, like I said, Loki, Cert Manager. That list could go on for days. So we really appreciate all the work that the Helm contributors have been doing. I mentioned Nginx Ingress, and I like to mention it because we actually use the gRPC backend that's released in Nginx, and gRPC being one of the CNCF projects. We use gRPC to host some of our APIs, and it's been really good for us. We use protobuf a lot already in ecobee for our messaging formats for Google PubSub, and it was a natural extension for us to use it with our APIs. gRPC comes with a lot of the host benefits, but it's that because it uses protobuf, we're able to really leverage that for the validation, the schema validation, and it came across as like a well-defined contract for integration between teams. And it's something that we really needed because with our squad model, that semi-autonomous model of teams, it was difficult to sort of integrate, and we didn't want to abuse REST like many people have abused REST and its flexibility before. So gRPC was a great way to sort of rein that in. There's a whole host of other performance benefits with gRPC, and we're still exploring some of that stuff that's available there. So our story doesn't end there yet. We're still exploring what's out in the CNCF community. Obviously, things like Vitess maybe will help change our database story for the thermostat team, or maybe things like OpenTelemetry will help improve our tracing picture. And things like Spiffy and Spire has also been on my radar for some interesting ways to use certificates for authentication. So really loving with what CNCF is doing. We're going to keep an eye with whatever's going on. So to wrap things up, you can say hi. You can email me if you have questions. If I don't get to them today, hit me up on LinkedIn, or I am in the Kate's Canada Slack. You can just add me and I'll try to get back to you.
Thank you very much, Jason, for your presentation. We just have time for 2 questions, and
Perfect.
hopefully enough, we only have 2 questions for you. First question from Younes. Younes is wondering what are the patterns that you are using for IoT security? In particular, he's thinking about the IoT devices security.
Yeah, so not specific to Cube, depending on which device, our thermostat uses their own IoT stack. It's our own homegrown stack. And again, leveraging mutual TLS. For some of our newer products, we started to dabble a little bit with Google IoT Core to help manage those configurations and device rollout. And again, I think that uses like MQTT and their own MTLS under the covers as well.
Thank you. And the second and last question is, does your architecture with Metal LB support IPv6 load balancing? Actually, there's another question. Why did you choose Rancher instead of others such as OpenShift? Is it for cost perspective or rather security perspective or other reasons?
Yeah, good question. So does Metal LB support IPv6? I believe, yes, it does. Now, we don't run it with IPv6, mostly because we haven't properly set up our network. We haven't moved our network to IPv6 yet. And I'm not sure what that's on the roadmap in the near future. And why Rancher over others? I wasn't exactly in that decision, but if I had to guess, I think just out of the box with RKE, we had such a great experience. And RKE, I believe, is free from Rancher. There's no cost associated, so it came relatively well, and it worked well with all of our on-premise equipment already. So I think that was the primary reason, but I could double check with the team again.
Thank you very much.
Great. Thanks, Jason, for a great presentation. And all right, that's all the questions I think we have for today. Thanks for joining us. The Meetup recording and slides will be shared at our Slack channel. And we obviously, super excited to run our first event, and I really enjoyed, and I hope you guys did enjoy as well. We're looking for our next speakers for the next event, Cloud Native Stories. So please submit your talks. All the speakers today will receive CNCF swag, t-shirts. So if you're interested to get a swag as well, or just want to share what your company is doing, I think it's great to share what you're actually doing. We're always trying to bring good speakers, but I think it's also nice when we can share with us internally without, asking to bring some vendor to talk about something. So we're hoping these events will be successful, and we're going to rely on you for that. And we're looking forward to seeing you at future virtual Eastern Canada meetups. And with that, I think have a great day. Thanks everybody for joining. And we're looking forward to